While you are lying still in the dark tonight, something extraordinary is happening inside your body. Not one thing, 5 things simultaneously. 5 different organ systems running 5 separate, precisely timed biological programs, all coordinated by a single master clock in your brain, all dependent on the same thing to run to completion: uninterrupted sleep. The moment you wake up in the middle of the night, the moment you go from sleeping to lying in the dark, staring at the ceiling, you have interrupted all 5 of those programs at once. Not paused them, interrupted them, because several of them cannot simply resume where they left off. They restart, or they don't run again until the next night. And the person lying there thinking, "It's just 3 in the morning, this is annoying." That person has no idea what just stopped happening inside them. I want to walk you through the schedule, what your body is actually doing hour by hour, from the moment you fall asleep to the moment you wake up. Because once you understand what is running during those hours and what it costs to interrupt it, the phrase, "I woke up at 3, will stop sounding like a minor inconvenience and start sounding like what it actually is. Let's start from the beginning. The first 90 minutes of sleep, roughly 10 to midnight for someone who goes to bed at 10:30, are dominated by the deepest and most metabolically active stage of the entire night: slow-wave sleep. Stage 3, NREM. The phase where the electroencephalogram shows massive, synchronized delta waves sweeping across the brain in long, slow oscillations. The phase where neural activity quiets most completely. The phase where your body runs its highest value, most irreplaceable biological programs. The first and most significant of those programs is growth hormone release. The pituitary gland, a small structure at the base of the brain, releases growth hormone in a series of pulses throughout the day. But the largest pulse, by a significant margin, happens during the first deep sleep cycle of the night. A study published in the journal Cell in June 2025, which mapped the neural circuits responsible for this release, found that the largest surge of growth hormone of the entire 24-hour cycle is specifically linked to slow-wave sleep entry, to the transition from lighter sleep into deep delta-wave activity. Growth hormone is not a hormone for children and athletes. It is the primary driver of overnight tissue repair for every adult, at every age. It stimulates protein synthesis in muscle cells, rebuilding the microscopic damage from a day of physical use. It promotes bone maintenance and density. It drives fat metabolism, shifting the body toward burning stored fat during the overnight fast. And according to the Berkeley research team, whose 2025 study in Cell mapped the neural circuitry, growth hormone may also promote the cognitive alertness and arousal that characterizes the feeling of being genuinely rested, rather than simply having spent enough hours in bed. When you wake up during the first sleep cycle, when the phone buzzes, or the partner moves, or the noise from outside is loud enough to break through, the deep sleep is interrupted. The growth hormone pulse that was running, or that was about to run, is curtailed. It does not resume at full amplitude. The repair window for that night's first cycle has closed. 1 disrupted night. Minor. Months of disrupted first cycles. The cumulative deficit in tissue repair and fat metabolism becomes measurable. People who sleep lightly, or who consistently wake in the first half of the night, are not just tired. They are less repaired. Every morning, they are a slightly worse version of what they could have been. Now the second program. It begins in the same window, the first half of the night, and it is one that most people have heard something about, but have never had explained in a way that makes the stakes clear. The glymphatic system. Your brain is the most metabolically active organ in your body. It produces more metabolic waste per unit volume than any other tissue, and unlike the rest of the body, it does not have a lymphatic drainage system. It cannot clear its own waste through the lymphatic vessels that drain other organs. Instead, it has the glymphatic system, discovered in 2012 by researchers at the University of Rochester. During slow-wave sleep, brain cells physically contract by approximately 60%, expanding the spaces between them. Cerebrospinal fluid flows through those expanded spaces in waves driven by the pressure oscillations of deep sleep, washing amyloid beta, tau protein, and other metabolic debris out of the brain tissue and into drainage pathways that carry them away from the central nervous system. Glymphatic clearance drops by 90% during wakefulness, It runs almost exclusively during deep slow-wave sleep, and it is front-loaded. The greatest clearance happens during the first 2 sleep cycles, in the first half of the night. When you wake up at 3 in the morning, the brain's cleaning crew was mid-shift. The cerebrospinal fluid flow stops. The channels, those expanded intercellular spaces, begin to close as neural activity increases. The amyloid beta and tau proteins that were being cleared are no longer being cleared. They settle back into the tissue. This is not abstract. A study published in the Proceedings of the National Academy of Sciences, using PET imaging in human subjects, showed that a single night of sleep deprivation produced a measurable increase in amyloid beta burden in the hippocampus, the region most vulnerable in early Alzheimer's disease. One night. The cleaning that was interrupted left more behind than would have been there if it had run to completion. Now the third program, and this one runs later. In the second half of the night, roughly between midnight and 4 in the morning, which places it precisely in the window where most people who wake at 3 a.m. are interrupting it. The liver. Your liver is one of the most metabolically active organs in the body, and it runs on a strict circadian schedule. Every liver cell contains a molecular clock, a set of clock genes that cycle in a 24-hour rhythm, controlling when specific metabolic processes run. Published research in the journal Sleep in 2024 confirmed that cortisol, which peaks at the morning-wake transition and reaches its nadir around midnight, acts as the primary synchronizing signal for the liver's circadian transcriptome, the daily on-off program of gene expression that coordinates metabolic function. During the overnight window, roughly midnight to 4 in the morning, the liver runs its peak detoxification and metabolic processing. It clears the hormonal metabolites from the day, broken down estrogen, cortisol fragments, inflammatory mediators. It processes any alcohol consumed. It manages glycogen, releasing glucose into the bloodstream through a process called glycogenolysis when blood sugar drops too low, and suppressing release when blood sugar is adequate. In a healthy liver operating on its proper circadian schedule, this process runs smoothly. Blood glucose stays stable through the night. Hormonal metabolites are cleared efficiently. The liver finishes its work by the time the morning cortisol rise begins. In a liver whose circadian clock has been disrupted, through irregular sleep schedules, through late-night eating that sends feeding signals during what should be a fasting window, through alcohol that the liver must prioritize over all other processing, this program fragments. The detoxification is incomplete. The glucose regulation is less precise. And the most direct physical consequence is the one you know from experience. Waking up at 3 in the morning with a low-grade agitation, a slightly too fast heart rate, a mind that was not ready to be awake. The fourth program is the one that carries the most acute consequences when disrupted, and the one that makes the early morning the most dangerous period of the day for cardiovascular events. Your cardiovascular system runs a precise 24-hour pressure schedule. During deep sleep, blood pressure drops by 10 to 20%, a phenomenon called nocturnal dipping that is so consistent and so important that cardiologists use 24-hour ambulatory blood pressure monitoring specifically to measure whether a patient's blood pressure dips normally during sleep. People who do not show this nocturnal dip, called non-dippers, have significantly elevated cardiovascular risk compared to those whose blood pressure follows the expected overnight reduction. This nocturnal blood pressure reduction is not passive. It is actively produced by the parasympathetic nervous system, the rest and repair branch of the autonomic nervous system, which becomes dominant during sleep and reduces vascular resistance, heart rate, and blood pressure to their overnight lows. The heart gets its most complete rest during this period. Cardiac muscle receives its richest oxygen supply relative to demand. Then, in the early morning hours, beginning around 3 or 4 in the morning, the body begins preparing for the transition to wakefulness. The sympathetic nervous system begins to reassert itself. Cortisol begins its ascent. Blood pressure begins rising. Heart rate climbs. The blood itself becomes more viscous. Platelet aggregability increases. The tendency to form clots rises. A meta-analysis published in the journal Stroke that pooled data from 30 studies and more than 66,000 acute myocardial infarctions found a 40% excess risk of heart attack between 6 in the morning and noon compared to the rest of the day. A similar analysis of 19 studies and nearly 20,000 sudden cardiac deaths found a 29% increase in risk during the same window. The European Heart Journal confirmed in 2025 that rupture of aortic aneurysms, ischemic stroke, and hemorrhagic stroke all show the same morning excess, all sharing the same underlying circadian mechanism. The physiological transition from sleep phase autonomic quiet to wake phase sympathetic activation. The key phrase is transition. In people whose sleep is fragmented, who wake repeatedly in the second half of the night, who rouse at 3 or 4 a.m. and lie awake in an activated state, this cardiovascular transition is not occurring once, at a natural waking time. It is occurring multiple times per night. Each time they cycle from sleep to wakefulness and back again. Each cycle activates the sympathetic nervous system. Each cycle pushes platelet aggregability upward. Each cycle produces a blood pressure surge that, in a healthy cardiovascular system, is manageable, but in a system already stressed by age, inflammation, or arterial disease, contributes to cumulative mechanical stress on the vessel walls. This is why cardiologists ask about sleep fragmentation, not as a lifestyle question, as a cardiovascular risk assessment. The fifth program runs throughout the night but reaches its peak in the small hours, and it is the one that makes what you do not feel during disrupted sleep ultimately more consequential than what you do feel. Your immune system. Research published in PMC confirms that cortisol and the immune system run in precise opposition across the 24-hour day. During the night, when cortisol is at its nadir, immune cells are most active and most deployed. Natural killer cells, which identify and destroy virus-infected cells and abnormal cells. T lymphocytes, which mount targeted immune responses. The cytokines that coordinate immune activity. All of these are maximally operational during the overnight window when cortisol is low. This is not a redundancy. This is an evolved design. The immune system's most intensive work, identifying damaged cells, clearing debris, mounting surveillance across every tissue in the body, requires metabolic resources and cellular mobility that cortisol suppresses during the day, when those resources are needed for active function. The night is when the immune system is given the quiet, the hormonal permission, and the time to do its deepest work. When sleep is fragmented, this work is interrupted. Studies on shift workers, people whose circadian systems are chronically misaligned, show persistently elevated inflammatory markers, impaired immune responses to vaccination, and increased susceptibility to viral infection. The immune cost of sleep disruption is not immediate and visible, it accumulates. The person who wakes at 3 a.m. every night is not running their immune surveillance at full capacity. Not that night, not most nights. Over years, that immune deficit contributes to exactly the chronic inflammatory conditions that dominate the health landscape of people over 50. Elevated CRP, joint inflammation, vascular inflammation, cognitive inflammation. The quiet biological maintenance that the immune system was designed to run every night, undisturbed, has been running at reduced capacity for a decade. Here is what I want you to understand. When you wake up at 3 in the morning, when you lie there, frustrated, waiting to fall back asleep, you are not simply awake at the wrong time. You are watching 5 biological programs run out of time. The growth hormone repair pulse that your tissues depend on. The glymphatic clearing that your brain depends on. The liver's detoxification cycle that your metabolic system depends on. The cardiovascular quiet that your heart depends on. And the immune deployment that every system in your body depends on. None of these are metaphors. All of them are documented, researched, peer-reviewed biological processes with defined timings, defined mechanisms, and defined consequences when those timings are interrupted. So the question is not, why do I wake up at 3? The question is, what is consistently disrupting 5 simultaneous biological programs every night, and what do I do about it? The answer is usually one or more of the same mechanisms I have discussed in previous videos on this channel. A cortisol rhythm that has been dysregulated by chronic stress and fires too early. Blood sugar instability that triggers a hormonal rescue response in the early morning hours. Sleep apnea producing arousal events in the second half of the night. Magnesium deficiency that keeps the nervous system too activated to stay in deep sleep. Or late-night habits, screens, food, alcohol, that misalign the timing signals that every one of those organ programs depends on. The biology is not mysterious once you understand the schedule. Your organs know exactly what they are supposed to be doing at 3 in the morning. They have been doing it for every night of your life. Your job is to stop interrupting them. Try to protect the schedule tonight. Your body will know the difference.